Hello students. Today we are going to discussing the chapter circles. What is a circle? In your earlier classes you are studying some concepts. What is the circle? The circle is in the shape of the ring, and what is the area of the circle and perimeter of the circle. Like these concepts we are studying. Now we are studying the depth in the concepts. Okay, it is very important chapter for your intermediate IP examinations. More questions from this chapter. We have two essay questions and two 2 marks questions and one 4 marks questions. The total marks is 22 out of 75 marks. So it is very important for getting 100% in your 2B paper. Okay. So this is also very important role in IIT JEE Mains. So many questions are related to the concepts of the circle. So we must learn very strongly. Okay. So we are going to this topic. Okay, so this topic is very easy when you are understanding the concepts and diagrams. So the diagrams are very useful to easily calculate the problems. Okay, now we are starting. So start the topic. Okay, so we are studying this topic. First we are learn some concepts. What is the circle? What is the stand form of the circle? And what are the properties we are learn first. Okay. See that first we have to definition of the circle. What is the definition of the circle? See the diagram first. This is the center. Now we are taken. This is the fixed point. Okay. Now a point P is moving on the plane such that a constant distance from a fixed point. The locus of a point which moves in a plane such that a constant distance from a fixed point. That locus forms a circle. Okay, so see the diagram. So this is our circle. C be the fixed point and P is the moving point in the plane that moves a constant distance from the fixed point capital C. Okay, so that is the definition. See the definition once again. The locus of a point which moves in a plane such that a constant distance from a fixed point is called the circle. Okay, that is the mathematical definition of the circle. So what is here mathematical condition? The mathematical condition is the constant distance. That is Cp is a constant. That is our mathematical condition. So the locus of P forms a circle. Okay, the path of P forms a circle. Here the fixed point is called the center and the constant distance is called the radius and the path of the point P forms a circle. That is the concept of the circle. That is the mathematical definition of the circle. So we have to find the problems given like this. We have to find the locus of a point, some point 2,1, which is 5 minutes away from the point 2,1. How to get the locus? this definition represents the fixed point is center and the constant distance is we are taken radius. So we are known the definition, then only we are solve the this type of questions. Okay, you are understood the definition. The circle, once again, the locus of a point which moves in a plane such that a constant distance from a fixed point is called the circle, where the fixed point is the center and the constant distance is the radius, and the path of the point P forms a circle. So this is the definition of the circle. Now next the simple theorem. Here we have to find the equation of the circle if you given center x1 y1 and radius r. What is the equation of the circle with center x1 y1 and radius r? The circle equation is x minus x1 whole square plus y minus y1 whole square is equal to r square. So this is the formula for finding the circle equation if we given center and radius. Center is x1 y1 and radius is r given, then we are getting the circle equation is x minus x1 whole square plus y minus y1 whole square is equal to r square. Okay, this is the our theorem. We prove this simple theorem. So given that the center is x1 y1 and radius is r. Now we have to find the circle equation. Now we have taken any point P on the circle. See the circle, our circle is this one. Taken P of x comma y be a point on the circle. Now we have to write the locus of P. That locus forms a circle. That is the locus of P is our required equation of the circle. Okay. Now we have to taken P of x comma y be a point on the circle. Okay. See the diagram. So P is a point on the circle. Here C be the center given x1 y1 and radius is also given r. So we have to given center and radius r. Now we have to taken a point P of x comma y, that is a variable point on the locus of the point P. Okay. Now we have to write the locus of P, that becomes a equation of the circle. So by the definition here CP is equal to r. So the constant distance, that is CP is always represents a radius. So CP is equal to r. Okay. Now we are writing the distance between C and P. We are given C is x1 y1 and P is here x comma y. So using the distance formula, we are writing the CP distance is square root of x minus x1 whole square plus y minus y1 whole square is equal to r. Now we are squaring on both sides. Then we are getting x minus x1 whole square plus y minus y1 whole square is equal to r square. Okay, this is the locus of P in xy. That is our required equation of the circle. So which is the required equation of the circle with center x1 y1 and radius r. The circle equation is x minus x1 whole square plus y minus y1 whole square is equal to r square. So this is the simple theorem. We have to given the problems center and radius. We are writing the equation of the circle with this formula x minus x1 whole square plus y minus y1 whole square is equal to r square. Okay. Next see the example. Find the locus of the point which moves in a plane such that a 5 units from the point 2 comma 1. This is the, for example, problem. Now we have to find the locus of the point which moves in a plane such that 5 units from the point 2 comma 1. So we have to given the point is fixed point is 2 comma 1 and constant distance is here 5. Okay, now we have to write the locus of the point P. That locus represents a circle. By the above definition, P locus forms a circle. So now we have taken let P of x comma y be a point of the circle, or let P of x comma y be the locus of the point. Okay, now we have to find the locus of P. See the diagram. P is x comma y be any point on the locus, and given C is 2 comma 1 this is fixed point, and the constant distance here given CP is 5 units, that is radius. By the definition of the circle, the fixed point C is 2 comma 1 is the center, and the constant distance R is the 5. Okay, we are getting the center and radius. Now we are write the circle equation, that is the locus of P represents here the circle. So the circle equation, the above theorem, the formula is x minus x1 whole square plus y minus y1 whole square is equal to r square. Here C is 2 comma 1 and r is equal to 5. Now we are at the circle equation. The required equation of the locus of P with center 2 comma 1 and radius 5. The circle equation is x minus x1 whole square plus y minus y1 whole square is equal to r square. Here x1 y1 that is the fixed point 2 comma 1, r is here 5. Now substitute in the formula. We are getting the circle equation that represents the locus of P. Therefore here the required locus of P is the circle with center 2 comma 1 and radius r is equal to 5 is x minus 2 whole square plus y minus 1 whole square is equal to 5 square. So this is our the locus of the point P. Okay, see the next what is the general equation of the circle? What is the general equation of the circle? See that the equation of the circle with the center x1 y1 and radius r is the circle equation. We are proving in the above theorem. What is the circle equation? X minus x1 whole square plus y minus y1 whole square is equal to r square. So that is the circle equation with the center and radius. Okay, now we are to expanding this equation. We are getting x square plus y square minus 2x1x minus 2y1 plus x1 square plus y1 square is equal to r square. Now we are expanding, we are getting this equation. Now we are taken minus x1 is g and minus y1 is f, and x1 square plus y1 square minus r square is equal to c. Okay, then the above equation becomes like this: x square plus y square, in the place of minus x1 is g and minus y1 is f, and x1 square plus y1 square minus r square is c. Substitute, then we are getting this equation: x square plus y square plus 2gx plus 2fy plus c is equal to 0, which is called the general equation of the circle. So this is the general equation of the circle. What is the general equation of the circle form? X square plus y square plus 2gx plus 2fy plus c is equal to 0. This circle is called the general equation of the circle. Here we are, the center is we have taken already, c is x1 y1 and radius is r. We have taken that circle and simplifying, and then we have taken minus x1 is g, minus y1 is f, and x1 square plus y1 square minus r square is equal to c. From that we are getting this general equation. So here the center is x1 y1 can be written is in the general equation form in g and f. So what is x1 here? Minus g. What is y1? Minus f. So the general equation of the circle center is C is equal to minus G minus F. What is the center of the general equation of the circle? Minus G minus F. That is nothing but the minus x quotient by 2 and y coordinate is minus y quotient by 2. That is the center of the general equation of the circle. And we are to take in here x1 square plus y1 square minus r square is equal to c. From that we are to write x1 is here minus g. Substitute y1 is minus f. And we are to substitute those. We are getting g square plus f square minus r square is equal to c. From that we are writing r square is equal to g square plus f square minus c. From that we are writing r is equal to square root of g square plus f square minus c. That is the radius of the general equation of the circle. Okay, what is the general equation form? X square plus y square plus 2gx plus 2fy plus c is equal to 0. What is the center of the general equation of the circle? Minus g minus f. And what is the radius? R is equal to square root of g square plus f square minus. So these are the formulas, very important. So we have to given the general equation of the circle. Now we are getting center and radius. Center is minus g minus f and radius is root of g square plus f square minus c. Okay. Next, note this. Here x square plus y square plus 2gx plus 2fy plus c is equal to 0, which is called the general equation of the circle. Next, note here the equation of the circle with the center at origin. What is the origin? 0, 0. And radius r is x square plus y square is equal to r square, which is called the standard form of the circle. So in the above we are discussing the general equation of the circle. What is the general equation of the circle form? X square plus y square plus 2gx plus 2fy plus c is equal to 0. What is the standard form of the circle? The standard form of the circle is center at origin and radius is r. The circle equation is x square plus y square is equal to r square. That circle is we are called standard form of the circle. Next, note, if the value g square plus f square minus c is equal to 0, then the circle is called point circle. Okay. So what is g square plus f square minus c? In our radius r is equal to root of g square plus f square minus c. This value g square plus f square minus c value is 0, then the radius becomes 0. So if the radius of the circle is 0, then we are called that circle is a point circle. Okay. Next, note, if g square plus f square minus c is greater than 0, if g square plus f square minus c greater than 0, then the circle is called real circle. So if g square plus f square minus c greater than 0, then we are getting the real value of the radius. Okay, radius is real, we are getting that circle is called real circle. Okay, next note is if g square plus f square minus c is less than 0, then the circle is called imaginary circle. Okay, here g square plus f square minus c is less than 0, then radius is we are getting imaginary number. So we are getting only imaginary circle. So real values we are getting real circle. If g square plus f square minus c is equal to 0, the radius becomes 0. Then the radius is 0, then that circle is called point circle. If g square plus f square minus c is greater than 0, then radius r is a real value, then we are called that circle is called real circle. If g square plus f square minus c is less than 0, then the circle is called imaginary circle. So in the objective questions, if you given some equation of the circle, what is the circle? In options, real circle, imaginary circle, or point circle, or none of these. So we have to find g square plus f square minus c. Then we have defined that given circle forms a real circle or point circle or imaginary circle. Okay, this concept is very important. Okay, next one. Note here the second degree equation ax square plus 2hxy plus by square plus 2gx plus 2fy plus c is equal to 0 represents a circle if and only if. So this general equation of this circle represents a circle. The general equation, that is the second degree equation. Okay, ax square plus 2hxy plus by square plus 2gx plus 2fy plus c is equal to 0. That second degree equation represents a circle if and only if. What are the conditions? See that. First condition is a is equal to b. Here a and b not equal to 0. And if a is equal to b, that means the quotient of x square is equal to the quotient of y square. That is the first condition. And h is equal to 0. What is h here? The quotient of xy. The quotient of xy is here 2h. That will be 0. Then xy quotient is 0. Okay, that is another condition. So if these two conditions satisfies, then the second degree equation represents a circle. So we are applying these conditions. Then the given equation becomes, we have to substitute here b is equal to a and h is equal to 0. Then the equation becomes here ax square plus ay square plus 2gx plus 2fy plus c is equal to 0. Now we are dividing a with a on both sides. So then we are getting x square plus y square plus 2gx by a plus 2fy by a plus c by a is equal to 0. Okay, that is the circle that is in the stand form. Okay, x square quotient is equal to y square quotient and xy quotient is 0. So this is the stand form or general equation of the circle. How to write the center and radius of the general equation of the circle? Center is minus x quotient by 2 minus y quotient by 2. Now we are writing for this circle. Here center is minus g by a comma y quotient minus a by b. And we are writing the radius is r is equal to here root of g square plus f square minus c by modulus of e. Okay. In the above formula, r is equal to root of g square plus f square minus. Here, what is g? That is g by a. What is f here? F by a. C is here? C by a. Okay, these are substitute and simplifying. Then we are getting the radius r is equal to square root of g square plus f square minus c by modulus of a. So, these are the center and radius of the general equation or the second degree equation. Okay, in this form. Next, concentric circles. What are the concentric circles? Two or more circles are said to be concentric circles if their centers are the same. Two or more circles having the same center, then we say that these circles are concentric circles. See the diagram. This is one circle and this is another circle and another circle. Okay, these three circles having the same center, then these circles are concentric circles. Okay, what is the definition of the concentric circles? Two or more circles having the same center, then we say that these circles are concentric circles. Centers are same. Okay, that must be very important. So, how to write the concentric circle if we given one circle? Okay, see that the equation of the concentric circle with this circle x square plus y square plus 2gx plus 2fy plus c is equal to 0 will be in the form of x square plus y square plus 2gx plus 2fy plus c dash is equal to 0, where c dash is any constant. So first circle, constant circle, is of the form x square plus y square plus 2gx plus 2fy plus c dash. For these two circles, only constant is differ. The remaining part is same. Why? The centers are the same. So centers are the same. Then these circles are concentric circles. So now we are writing a concentric circle of the given circle x square plus y square plus 2gx plus 2fy plus c is equal to 0 is of the form x square plus y square plus 2gx plus 2fy plus c dash. Only constant is differ. The remaining part is same. Since these two circles are concentric circles. Okay. Now, what is the unit circle? What is the unit circle? The radius of circle is 1, then it is called unit circle. Radius is 1, then that circle is called unit circle. Okay, you know that. Next, length of the intercepts made by the circle on the coordinate axis. If we given a circle, that circle makes an intercept on x-axis or in y-axis. Now we are calculating the x-intercept of the circle, that circle made by intercept on the x-axis. So see that if s is x square plus y square plus 2gx plus 2fy plus c is equal to 0, with the circle intersects the x-axis, then the length of the x-intercept is equal to the formula 2 into root of g square minus c. That is the length of the intercept made by this circle s is equal to 0 on x-axis. Now we are to proving this result. This is the x-axis and this is y-axis. This is our circle. This circle intersects the x-axis in capital A and capital B. Okay. Now we have to find the length of AB. That is the circle intercept on x-axis. Now we have to find the length of AB. That is the length of the x-intercept made by the circle. Okay. Now how to find the length AB? The circle intersects the x-axis. So then the coordinates of A and B are zeros. Since on x-axis the coordinates of y are 0. Okay. Now y coordinate is 0. That is y is equal to 0. We have to substitute in the given equation. So see the proof here. Since the given circle intersects the x-axis at capital A and capital B, we are saying that put y is equal to 0 in the given circle. Then the equation becomes x square plus y square plus 2gx plus c is equal to 0. We have to substitute y is equal to 0. Then y term will be cancelled. Then x square plus 2gx plus c is equal to 0. This is a real circle. So x has real values. So discriminant delta is greater than 0. It has two roots. So this is the equation in x. It has two roots. Those are the values of a and b x coordinates. Okay. Now we have taken these roots are say x1, x2. So what is the sum of the roots x1 plus x2? So this is the quadratic equation in x. What is the sum of the roots? Minus x quotient by x square quotient. That is minus b by a. So what is here x1 plus x2 is equal to minus 2g and product of the roots is c. That is c by a. That is c by 1. That is c. Okay. So we are getting x1 plus x2 and x1 x2. Now we have to find the length of AB. What is here length of AB? X coordinate of A is x1 and x coordinate of B is x2. What is the length of AB? Okay. So the length of AB is nothing but the modulus of x2 minus x1 or x1 minus x2. What is the formula? Modulus of x1 minus x2 is equal to square root of x1 plus x2 whole square minus 4 x1 x2. We are getting x1 plus x2 and x1 x2 values in the above. Substituted here. What is x1 plus x2? 2g. We have to substitute, that is 2g whole square, that is 4g square, minus 4 into x1 x2 is c, that is 4c. Okay, 4 is common. We are getting 2 into root of g square minus c. That is the length of AB. That is length of AB is modulus of x1 minus x2. So therefore, the length of the x-intercept made by the given circle is 2 into root of g square minus c. Similarly, we have to find the y-intercept. Okay. In the same way, we find y-intercept. That y-intercept is 2 into root of f square minus c. So these are the intercepts made by the circle on the coordinate axis. What is the x-intercept? X-intercept is 2 into root of g square minus c, and y-intercept is 2 into root of f square minus c. Okay. Next, note here, if g square minus c is equal to 0, that is, if x-intercept is 0, then the circle is touches x-axis. In the above, we are to observing the x-intercept is 0. If g square is equal to c, x-intercept is 0. If x-intercept is 0, the x-coordinates x1 is equal to x2. Those are coincide. The x1 is x-coordinate of A and x2 is x-coordinate of B. These A and B are coincided. Okay, these A and B are coincided. Then the circle touches x-axis. See that the notes here we are observing g square is equal to c, that is x1 is equal to x2. Then the circle touches x-axis. If g square is equal to, if f square minus c is equal to 0. Okay, see that f square minus c is equal to 0. That is, what is y-intercept? 2 into root of f square minus c. If f square minus c is 0, then y-intercept is 0. The y-intercept is 0, then this circle touches y-axis. Another observation, if g square is equal to f square is equal to c, then the circle touches both the coordinate axes. These are the conditions. So if x-intercept is 0, then the circle touches x-axis. If y-intercept is 0, then circle touches y-axis. Then these are the conditions. If g square is equal to c, touches x-axis. If f square is equal to c, the circle touches y-axis. And if the circle touches both the x-axis and y-axis, then the condition is g square is equal to f square is equal to c. These are the conditions when the circle touches x-axis or y-axis or touches both the coordinate axis. Okay, see the observations. These are very important. Okay, next one. See that cases in above in the diagrams. If g square is equal to c, that is x1 is equal to x2, then the circle touches x-axis. See the diagram here. The circle touches x-axis. The second case, if f square is equal to c, that is y1 is equal to y2, then the circle touches y-axis. Okay, see the diagram. The circle touches y-axis. Okay. Next, third case is if g square is equal to f square is equal to c, then the circle touches both the coordinate axis. So this is x-axis, this is y-axis. In this case, the circle touches both x-axis and y-axis. Okay, this is the condition. G square is equal to f square is equal to c. Then the circle touches both the coordinate axis. See the diagram. Okay. Next, in that case, the x coordinate and y coordinate of the center of the circle are equal. See the diagram. From this diagram, so x coordinate and y coordinate are equal. Okay. In this case, x coordinate and y coordinate of the center are equal. Let it be A. Then the center is we are taken C is A comma A, and also the radius is also A. From this diagram, the center is A comma A and radius is also A. So if any circle touches both the coordinate axis, then we have taken the center as A comma A and radius is also A. Okay. If the circle is in the first coordinate, we have taken A comma A. If the circle is in the second coordinate, minus A comma A as the center. If the circle touches both the x-axis and y-axis in the third coordinate, we have taken center is minus A comma minus C. Radius is in all cases we have taken R. R is always positive. If the circle touches both the coordinate axis and in fourth coordinate, then we have taken center is A comma minus C. Okay, and radius is A. So this concept is very important in objective. So if you given a center 2 comma minus 2 and touching both the coordinate axis, then write the circle equation. The radius is not given, but if the circle touches both the x-axis and y-axis, then what is the radius? The radius is modulus of x coordinate or y coordinate. That is the radius of the circle. Okay, this concept. Okay, next note here. See that the equation of the circle touches both the axis, both the coordinate axis in the first coordinate. Then the circle equation we are taken center is C is A comma A and radius is also A. Then the circle is we have taken the form x minus A whole square plus y minus A whole square is equal to A square. So this is the circle touching both the coordinate axis in the first coordinate. Okay, now see the example related to this concept. Some problem here. Find the equation of the circle touching both the coordinate axis and passing through the point 2 comma 1. This is our problem. How to solve? So here the required circle touches both the coordinate axis and passing through the point 2 comma 1. See the solution. Since the required circle touches both the coordinate axis, then the equation of the circle we are taken x minus A whole square plus y minus A whole square is equal to A square. We are already saying in the above note. This is the required circle. If this circle is touches both the coordinate axis, center we are taken A comma A and also radius is we are taken A. Then the circle is of the form x minus A whole square plus y minus A whole square is equal to A square. See the diagram. This is the x-axis and this is y-axis. This is a circle passing through the point 2 comma 1 and touching both the coordinate axis. Okay. We have another circle which is also passing through the point 2 comma 1 and touching both the coordinate axis. Okay. So these two circles passing through the point 2 comma 1 and touching both the coordinate axis. Okay. So one is a small circle and another is a bigger circle. These are the two circles passing through the point 2 comma 1 and touching the both the coordinate axis. Now we have to find these circles. Okay, how to find the circles? We are taken here center is A comma A and radius is also A. That is the required circle. How to find the A value? Okay, see that. This is our diagram. The required equation of the circle passing through the point 2 comma 1. Okay, our required circle is x minus A whole square plus y minus A whole square is equal to A square. That circle is passing through the point 2 comma 1. Okay, this point substitute in that equation. We are getting in the place of x is 2 and in the place of y is 1. 2 minus A whole square plus 1 minus a whole square is equal to a square. Now we are simplifying that 4 plus a square minus 4a plus 1 plus a square minus 2a is equal to a square. From that we are getting a square minus 6a plus 5 is equal to 0. This is the quadratic equation in A. Okay. Now we are factorizing that 6a can be written as minus 5a minus a, and a is common. We are getting a minus 5 into a minus 1 is equal to 0. From that a is equal to 5 or a is equal to 1. We are getting two values for a. So if a is equal to 1, then the circle is smaller circle. If a is equal to 5, then it is a bigger circle. Okay, we are getting the two circles. These two circles passing through the point 2, 1 and touching both the coordinate axis. Okay, write the circles. The required circles are x minus 5 whole square plus y minus 5 whole square is equal to 5 square, that is 25. And another circle is x minus 1 whole square plus y minus 1 whole square is equal to 1. We are taken centers 1, 1 is one circle and 5, 5 is the another circle. The radius is the same. So if the center is 1, 1, the radius r is also 1. If the center is 5, 5, the radius is also 5. From that we are getting these two circles. These are the required circles passing through the point 2, 1 and touching both the coordinate axis. Okay. Thank you.